Hello everyone, in today's video I will explain you how to compute simple moving averages of stock time series in Python and Pandas. So what you can see over here is a time history of the stock price of the Apple company. The blue line is the actual closing price after every trading day, and the red line is the computed moving average. I'm going to introduce and explain you two methods for computing moving averages. The first manual method is based on writing a for loop. This might be a tedious method, however it's very instructive. And the second method is based on the Pandas. Namely, in Pandas, and Panda is a library for manipulating data structures in Python, there is a nice function called rolling that can be used to compute the moving average. And I'm going to introduce both of these methods. As always, I have created a post that nicely summarizes everything that I will be explaining in this video. So if you don't have enough time to watch this video, you can simply read this post and everything will be clear. So I'm going to place a link to this post in the description below this video. But before we explain the Python codes, we first need to define moving averages. So what you can see over here is a graphical representation of time series. On the x-axis we have a discrete time, and on the y-axis we have the values of time series. For example, x of k, in this notation, x subscript k represents the value of a quantity at a discrete time instant k. Now, the moving average of this time series, of the time series xk, is nothing less than a new variable that is a function of time series values in past. The moving average is equal to 1 over p multiplying the sum, where the summation starts from 0 and ends up at p minus 1, x k minus I. If you expand this sum, you will obtain z of k is equal to 1 over p xk plus xk minus 1 until the last index, and the last index is p minus 1. So you obtain x k minus p plus 1. Now, for example, let us choose p equals to 2. So what do we get? We obtain z of k is equal to 1 over 2 multiplying xk plus xk minus 1. So this is the moving average of xk and xk minus 1 at the time instant k. Let's see what happens at the time instant k plus 1. So if we shift the index, the time index, for one step in the future, we obtain something that looks like this: xk plus 1 plus xk. So what is the conclusion over here? The conclusion is that the moving average at the time instant k is computed by averaging the values of x of k starting from the time instant k until certain past window p. For example, if the past window is equal to 2, then we are summing up xk plus xk minus 1 and dividing it by the past window. And if we want to compute the moving average at the time instant k plus 1, we proceed similarly. We take this value, xk plus 1, we take the past value xk, we add them together, we divide by 2. So what do we have here? We are basically having a moving window. So at xk, we take these two values and average them out. At time instant k plus 1, we now take these two values and we average them out. Then, at time instant k plus 2, we always take two recent values and average them out. So this is the graphical explanation of the moving average. Okay, now that we know what moving averages are, we can proceed with the Python code. So what you can see over here is my Python development environment. I'm using the Spider development environment since it reminds me of MATLAB. For example, it's very easy to execute the code lines. For example, you can just select the code lines and you can just run them. And this is very similar to MATLAB. It's very easy to debug, it's very easy to execute. Okay, so let's start. The first step is to erase the workspace. So I'm going to type reset and I'm going to click on yes. Great, let's see our workspace. Now it's completely empty. The next step is to clear the screen. Good. So let us proceed with importing the standard libraries. I'm going to import Pandas, then I'm going to import NumPy, then I'm going to import the plotting tools, and finally I'm going to import Pandas data reader. This library is used for downloading the stock prices from internet. So let us import the libraries, and the next step is to import the statistics library. Good. Now all the libraries are in computer memory. The next step is to define the parameters. The parameter on the code line 27 is the moving average window, or our parameter p used to define the moving averages. So the p is equal to 40 in this code. The next step is to define the dates for downloading the data. So I'm going to download the stock prices starting from the start date, and the start date is January 2016 and the end date is January 2021, since we live in 2021. So let us execute these code lines. Good. And you can always check what is in your Python memory or in your workspace by typing whos. Okay, the next step is to define the file name for storing the data. It is always a good idea to store the data on your local computer once you download it from internet. So I'm going to define the file name for downloading the data. In order to download the stock prices, you need to know the symbol of the stock. For example, the symbol of the Apple stock is AAPL, and I'm going to define this symbol. On the other hand, if you want to download, for example, stock prices of Boeing, you will type stock symbol is equal to BA, because the symbol of the Boeing stock is BA. You can look it up online and you can find the symbols of all the companies of the New York Stock Exchange on Yahoo Finance. Next, I will download the data from internet and save it to a file. And I'm going to use a very robust way for downloading and saving the data. So, first, I'm going to try to open my data from my local computer, assuming that the data has been previously downloaded. So I'm going to type try, and I'm going to execute this code line, data pd read pickle, from the file name, where the file name is given over here. So if the data is saved to your local computer, then this block will be executed. However, if this function returns you an error or an exception, then this code block over here will be executed. So if the error is being returned, then There is no file name on your computers with stored data, so we need to download it. So if the exception is being thrown, then these code lines will be executed. Basically, the main code line is the one over here, and this code line is used to download the data from internet. You specify to the Pandas get data Yahoo function as the first argument stock symbol, as the second argument the start date, and as an end argument the end date. And finally, in the same code block, we will save it to a file. So let us execute these code lines. So what do we see over here? We see that only the first block is being executed, since before even making this video I have downloaded and stored data on my computer. So let us inspect the data. If we write data.head, we will obtain the first few rows of the data frame object. So the first column is the date, the second column is the highest price during the trading days, the third column is the lowest price during the trading day, and for us the most interesting column is the last one that gives us the adjusted closing price, and we are going to compute moving averages of the adjusted closing price, since this adjusted closing price is often used to analyze stocks. We can also plot the downloaded data by executing this code line. So I'm selecting the last column and I'm just plotting it, and here how it looks. We can see over here the COVID situation. The stock dropped dramatically and it goes up, and keeps on going until it crashes again. Our main goal is to compute the moving averages of the adjusted closing price. Consequently, we need to extract the column corresponding to the adjusted closing price from the data object. We can do that by executing this line of code. And by evaluating the code line 65, we can obtain the closing price time series. Now, in order to isolate the values stored in the closing price, you need to execute this line of code. So these are the values. Generally speaking, there are two approaches for computing the moving averages. The first approach is based on a for loop that will iterate over the values stored in the closing price. And the second approach is based on the Pandas rolling function. First, we explain the approach based on the for loop. In order to implement this approach, we need two variables. The first variable, called computed moving averages, is used to store the final values of the computed moving averages. The second list, called batch, is used to store the closing price values belonging to the moving average window. The for loop is over here. This for loop iterates over the values stored in the closing price, so it iterates over these values. In the first step, we append the batch list with the current value of the price. For example, in the first iteration, this value will be stored in batch. Then in the second iteration, these two values, etc. In the final step, we simply compute the mean of the values being stored in the batch list, and we assign this value to the computed moving averages, or better to say, we append the list computed moving averages. For example, in the first iteration, the batch list contains this entry, and the computed moving averages is simply the mean of this entry, and this is the entry itself, so the computed moving averages will contain this entry. In the second iteration, the batch is being appended and it contains these two values, And in the final step, we compute the average or the mean of these two values, and we append the computed moving averages. And we keep on repeating this process. However, in every step, we check if the length of the batch or the number of values stored in the batch list is larger than the moving window or the window used to store the entries. If that's the case, then we basically erase the first entry. And in this way, we implement a moving window. So the window, for example, if the window size is 5, first it will look like this, and then it will look like this, and it will look like this, etc. So it will move over the closing price values. Once we have computed the moving averages, it's a good idea to store them. And we are going to store them as another column of our original data object. This line of code is used to perform this task. So before executing this line of code, the data object will look like this. We will have 1, 2, 3, 4, 5, 6 columns, and the last column will be the adjusted closing price. However, after executing the code, the data object will contain an additional column, and this additional column will correspond to computed moving averages. So let us a little bit inspect this code line. So what do we see over here? The data object, or the Pandas data frame object, has a method called assign. And the first argument is the name of the new column. And we are saying that the new column should be equal to a new Pandas series object that will have as its values computed moving averages, and the index should correspond to the index of the original data object. That is, the index values are the dates. Magic, right? That's the power of Pandas objects and Pandas data frame objects. It's so easy to manipulate with time series. These code lines are used to plot the results. By executing them, we obtain the graph from the beginning of this video. The red line is the computed moving average, and the blue line is the actual price. Now, the second method for computing the moving averages is based on the Pandas rolling function. This line of code, only this line of code, substitutes these 7 or 8 lines of code. So, how to compute moving averages using built-in Pandas function? Well, we first select the adjusted closing price column, then we call the rolling function, and as an argument of the rolling function, we specify the window, the moving average window, over which we will perform some certain action, and at the end we specify the mean function. So what we are saying here, take the rolling window equal to moving average window and perform the mean. You can also call the sum function or some other function over here. You can look into the help of the rolling function. If we execute this, we will obtain our results. Okay, now let us compare the manually computed moving averages with the moving averages computed using the Pandas rolling function. So what I'm doing over here, I'm plotting on the same graph moving averages computed using the for loop and using the Pandas rolling function. And here are the results. You can see a perfect match, except this initial interval where Pandas rolling function returns undefined values. And you can verify that by just basically looking into the moving averages pandas, and at the beginning you will obtain these undefined values. And if you count the number of undefined values, you will see that the number of undefined values correspond to the moving average window. So what's happening over here? The pandas rolling function simply ignores the first moving average window number of entries and starts to compute the moving average after moving average window has been passed. This is because in the definition of the moving average, the sum goes from I is equal to 0 to the moving average minus 1. And the moving average is basically not defined for the time index starting from 0 to the moving average window. However, in my for loop, I am basically initializing the moving averages, or I'm basically initializing the undefined values with zeros. Okay, thank you very much for your attention. I hope that you enjoyed this video. If you like this video, please subscribe or support my channel. Again, thank you very much and have a nice day.